Hello everyone. I'm very glad to be here. Sorry, I'm completely stressed out. I have not done this since a long time, so we'll try to survive. I would like to speak to you today about visual network analysis, but directly from the comfort of a Jupyter notebook cell. So first, a question. Has anyone here already used Gephi or Pajek or any kind of graph visualization software? Okay. So I will try to sum all this up and why we do that and why we apply this kind of methodology in social sciences, especially, and how we can transpose that to a Jupyter context. So hello everyone, I am Guillaume Plique. So I am a research engineer in SciencesPo's médialab in Paris. So I work for a very weird social sciences lab that was basically founded by Bruno Latour 10 years ago. And we intend to mix like 3 different profiles of people, so basically engineering people such as myself, designers, web application designers, and social scientists. So we try to mix all that and to do some innovative social sciences basically. So just a reminder about what a graph is or what a network is, because this is very polysemic and a lot of people will tend to use different words. So a graph is just like this here, which is basically a node link diagram also. So you have nodes that are sometimes called vertices also, that are linked by edges or links. And they have attached metadata, which means that the node can have a name, a label, a color, anything that you want. And the links also have attached metadata. And so we use this visual representation to be able to show the graph and embrace it visually at once, and to try and infer something from the data itself. So this is named visual network analysis. So this is a particular methodology which is a bit separate from statistical analysis, because of course you could analyze a graph as raw data and try to apply some statistical method to extract some knowledge from it. So basically you would use statistical information such as the graph's diameter, density, degree distributions, shortest path, and so on, centralities, and so on. And basically, you have to understand that graph theory is just a fancy name for linear algebra, because we are dealing with matrices, or very sparse matrices, at least. So the question is, should we try visualizing graph instead to be sure that we can like embrace the data at once and make the relevant information pop out? So this is a very famous diagram by Leonhard Euler about the city of Kaliningrad, of Königsberg, and Euler had some kind of enigma, mathematical enigma, which was, can you basically visit the city and cross all the bridges of the city to make sure that you are going to visit all of them, but cross them only once? So I'm sorry for the shabby explanation, but basically you have the city, you have like very nice bridges, and you are a tourist and you want to cross all the bridges, but you don't want to cross bridges twice because you are lazy. And so the question Euler asked was, is it actually possible? And if you look at the diagram and you try yourself to like design some path, and you try to modelize the problem as a graph, so each of the nodes here is a bank of the river, and each of the edges is a bridge, basically, can you find such a path? I won't let you very long, but basically there is no such path. This is impossible, but it is very complex mathematically to explain why this is. But if you like basically look at this and think about it a little bit more, you will like find the solution very easily. So this is a very, very misleading way to tell you that basically by visualizing and watching the graph closely, you can infer some things which are very complex mathematically speaking. So this is why nowadays, like, some people will tend to use visual network analysis in some sciences and in social sciences in particular. So if we watch this table closely, you will see that we have a table of students in like an elementary school, and we have like 2 other columns which are basically we asked each of the students next to which student you would like to be seated first, and then a second choice. So we have a first choice and a second choice for each of the students. So if you look closely at this table, I think you will not be able to infer what's happening here, okay? It's very obscure. But if I show it to you using some visual network analysis, so here the nodes are students and the edges represent those choices. you will see stuff happening. So basically, you see that there are two main components of the graphs that we are looking at, and those two components are basically boys and girls. And we can also infer stuff, such as some students are more popular than others because they have more links and so on. So this is named, or this was named, a sociogram, and it was invented by Moreno in the 50s. And it's a very powerful way at looking at some data. So this is a very old example, and here, basically, Moreno decided to place the nodes by hand on the screen, which is very tedious, and he drew the things himself on the screen. And then he tried to find a way to display the information. But since then, we learned as scientists to use more information when we try to visualize some data. And so it goes back to Jacques Bertin, so a Frenchman, and his visual variables and how you can use color, use size to represent information, numerical information on screen. So the idea here is to use Bertin's visual variables on a graph. So for instance, you are going to color the nodes differently, you are going to size them differently, you are going to use a thickness for the edges, and you are going to refine the visualization that you are able to make using some graphs. And so nowadays, you could even use advanced statistical tools such as community detection in a graph or spatial layouts, how we would position the nodes in space automatically, to draw those kind of maps, which are basically symbolical representation of the data that we are trying to analyze. And by looking at those maps, as one would with geographical maps, you are able to infer some basic information about the structure of the data. So you can see communities, you can see what nodes are able to bridge from one community to the other, and so on. And you can explore data a little bit more intuitively. So those representations are still a bit complex, and one should be wary when analyzing them, because they have very typical food guns, because the representation is isotropic, which means that the only things which is important is the distance between the nodes, basically, and not the position on screen. X and Y has no meaning. So be wary of that. So the question now is how we perform this kind of methodology. So how do we apply visual network analysis, first on desktop, historically, and now on the web? So traditionally, the grandfather of visual network analysis was named Pajek. So some of you may know Pajek, but it's quite old now, so I'm not expecting you to. But the most known nowadays is named Gephi. So this is a desktop tool that you can install on your computer, and you can make it process some graphs which are stored in data formats such as the GFX or GEXF format, which is an XML variant for graphs. And you will be able to do this kind of work, basically. But since then, web browser evolved, and we can now use web browser to render very complex stuff using Canvas, WebGL, SVG, and so on. And so people have caught up and are now trying to basically visualize networks directly from web browser without needing any kind of installation. And so this is often made using a library which is named sigma.js. And it stemmed a lot of different web applications, such as Minivan here, or Nancy, or Retina, or Gephi Lite, and so on, and so on, and so on. So you can use all of them. But the question is, how could we design an app for us? And by us, I mean social sciences data engineers. Because we are a very particular public, and we are not the same as basically students or PhD students. We have specific needs. And often, I think all of you know this kind of process when you're working on data. Basically, you are going to collect data, and then you are running some computation on the data, you are filtering, aggregating, and so on. And then you are going to analyze the data or visualize the data. And then, by doing so, you are going to go back to the computation step and go back to the data collection step. And there is an iterative process here. And so the question here was, are we able to design a desktop app or a web app able to do so? And the fact is, we cannot. So we try to do so by designing a web tool that is named Nancy. You actually have a screenshot of that here. So Nancy is basically a very streamlined version of Gephi that people can use to display graph and try to explore them. But the fact is, it does not fit very comfortably within this framework here, because you need to basically create some kind of data file, open it in an application, visualize some stuff, download it again, reprocess it, re-upload it to the application, and over, and basically you are losing a lot of time. So the question was, how could we do this more efficiently? And while reflecting upon that, we basically stumble upon the Jupyter notebooks, which are basically like the perfect tool for that. So you have computation in Python, you are running your cells, and you can display interactive elements within the output of the cells. So the correct solution would be, in fact, to display the network like in the Jupyter notebook cell. And so this is how we came to invent ipysigma, which is a weird name, but all the ipy widgets have a weird name. So this is an open source widget that you can install using pip, basically. And it works using either networkx, which is a very famous graph library for Python, or igraph. And then you can install ipysigma, and then you can start doing some visualization of graphs within a Jupyter notebook. But we are going to demo this, and hopefully it will work and not fail miserably. So I'm in a Jupyter cell here. I will first import. Should I zoom up maybe? Okay. So I'm going to import networkx as nx because this is the way. And then we are going to import a widget named sigma. Sorry, I'm typing very badly. From ipysigma. Okay? And so the second step will be to load some data from my computer because we don't have much time. And so I'm going to read a file containing a very, very famous graph, which is named Eurosys, which is a graph that was made by Franck Guitala and Mathieu Jacomy, and who displays basically a web corpus of European research institutions and how they relate to each other on the web. Only on the web. Yes. So you can see that this graph here has basically 1,000-ish nodes and some edges, of course, and some like 6,000, 7,000 nodes. And so we are going to use the Sigma widget on this, and now we have the graph on screen. Okay? And so this is not an image, this is completely interactive, so you can zoom, you can pan, you can search for some node here, if I want to find this node here, and you can access the metadata that is attached to some node, and you have a legend, you can filter, and so on. But if you watch closely this graph, you should agree with me that this is not completely readable. This is actually completely noisy. That's because the graph is not specialized already. So we need to find a position for the nodes. And so typically, people who use Gephi would apply some kind of layout algorithm. And the state of the art for this, in social sciences at least, is named Force Atlas 2, which is an algorithm that is iterative, and there is no way of actually knowing when to stop. So I need to rely on you, the user, to do so. So you are going to click on this button here. You are going to see the algorithm run, and I need to basically tell it when to stop. Okay, so now we are looking at a graph which is a bit more understandable. We have clusters, and we have basically a kind of center-periphery thing going on here. So, of course, now that we have a graph, it would be better to maybe try and start tweaking the visual variables of the graph so we may see something better. So if we click on a node here, you shall see that basically those nodes have two attributes. So remember that the nodes are European institutions related to research. And in the attributes, you have a country and you have an actor type, which is the kind of institution. So what I propose now is to use basically the country of the node as their color. So I will tell the widget, okay, actually your color will be the country of the graph. And I should have something which is colorful. Okay, do you see what's happening now? So we have clusters, and actually those clusters are explained by the country of origin of the institution. Yes. And so basically, the widget shows some kind of color palette for you and try to map basically different countries to different colors so we can try and see things better. Another thing that we can do maybe also is to give some kind of size, because here it's not very readable. So we are going to do something which is very common, which is to map the size on the degree of the node. So the more a node is connected, the bigger the node will be. And then we can start to read other things. So some nodes are more important than others, and so on, and so on, and so on. Yeah, so you have to understand that basically everything can be customized on this representation, and I will try and list them afterwards. But I need to demo a last thing before I come back to the slide. If some of you already did this kind of work, you should know that it's very hard to compare two categorical information on the same node, because you can't have like two colors on a node or it starts being messy. So the ipysigma widget also exports something which is a grid, which is basically a small multiple grid of a graph that will be synchronized with each other. So if I take my graph here and I say, okay, the node size will be the degree, once again, and I add a view of the graph where the color will be the country, and I add another view where the color will be the actor type. Here, I should have this. So I have a grid of views which are completely synchronized to one another. And so if you want to compare like local places of the graph, like so, while having two different categorical informations, you can do it. So you can synchronize stuff like this and try to compare different graphs very easily and conveniently. Yeah, so that's mostly it for the demonstration, which kind of worked, I hope. So you have access to a treasure trove of different visual variables. So you can use a color, saturation of the color for the node, a size for the node, labels. You can tweak the labels. You can tweak the border of the node. You can add a color for the border. You can have a pictogram. You can have a shape. You can have halo if you want to display some kind of heat map beneath the nodes. And for the edges, you can tweak like the color, the type, the size, the curveness, the label, and so on. So if you want to display a very, very ugly graph, you can. So you can like display small multiples, as I told you. And finally, something which is a bit funny if it loads. Okay, you can use like ipy widgets to basically produce a static embed of the graph and create like something which is an interactive graph widget that you can embed statically in a website. So this here is an iframe on the widget. Yeah, so for the future direction, I would like to be able to explore some specialized representation that are not covered by the work here, namely temporal graphs, so how a graph evolves in time, which is actually quite hard to represent. I want to have like specialized representation for bipartite graphs, so graphs who have like different types for the nodes. Let's say students on one side and teachers on the other, and how they interrelate. And I want to be able to better support various incarnations of Jupyter, because like Jupyter runs on notebook, on the browser, you have a lab, you have Colab, Google Colab, which is very used by students, VS Code, no, and it's very messy to be able to make sure that the notebook will run correctly in every instance. Yeah, and so like as a closing remark, I want to elaborate on the difficulties of developing custom widgets for Jupyter. So I did all this using ipywidget and by extending ipywidget. And so you have like a repository that you can clone and you can try to adapt them to your code. But the documentation is a bit all around the place, and like various versions coexist, and you have to basically squint very hard to know which version you are using and try to do that. So it's a lot of trial and error. It's a bit like old school web development when you have to like reload everything each time you want to test something. Sorry. And you have a lot of annoying warnings in the console that I cannot find a way to suppress. So if someone can help me here, please, because I'm very maniac and I can't bear those warnings. Everything you saw is, of course, open source. So you have a GitHub repository in the documentation there. The slides are also available on the web, and you have a demo of the embed that's here. Related to the dependencies, so everything was built using JavaScript, of course. So I did not tell it, but sigma.js is actually a WebGL renderer, so it's actually quite performant. So you should be able to display 10,000 of nodes and up to 100,000 edges, if your computer allows it. But basically, the bottleneck is the communication between Jupyter and the web view. It's not the rendering itself. Yeah, so it was built on graphology, which is basically networkx, but on the JavaScript side, and sigma.js, which is the rendering brick of all this. Yeah, that's it. Thank you very much for listening.
Thank you very much, Guillaume, for this great talk and for the flawless demonstration. So I had a lot of technical questions that you actually answered during the demonstration, which is perfect. So I had a more like a general one. How hard is it to get the social scientists to at least try to play with this kind of programming tools like notebooks and Jupyter?
I think there was a talk about this particular question like yesterday, and so I'm not able to answer it, but because I live in a place where social scientists actually develop and use those tools. So I don't really know.
Yeah, that's a privilege for programmers, I guess.
Yeah, but I'm not sure, like on a philosophical level, that social scientists should learn how to use Python. And we also it's not that they it's a very specific skill, and sometimes you want to spend the time that you are going to acquire those skills to basically do stuff. And we also, like as a lab, provide a lot of UI and like programs that are geared toward people who do not code and don't intend to learn how to do it, basically.
Yeah, that's a great question. Sorry, but just in this case, why build something with a notebook instead of like a GUI that's completely closed and that social scientists cannot enter in?
Yeah, because we are actually like living in a split community where we have like social scientists who code and social scientists who do not code. So this is for social scientists who code, but basically the first target of this tool was actually myself. So it's very useful to me, at least.
Yeah, that's a. At least, yeah, that's good.
Just what is the name, please, of the algorithm used by Sigma to reorder the nodes of
the spatial layout algorithm? It's
thank you.
The algorithm is named Force Atlas 2. Force Atlas 2. It was invented by Mathieu Jacomy. And it's a force layout algorithm. So basically, it works by you have nodes in the physical space, and if they are linked, they are like drawn to one another as if there is a spring between them. And every node is repulsing every other node, and there is a gravity that like basically attracts everything at the center. So you run this iteratively, and it performs a spatial layout of nodes. If you know Tisney and UMAP, it's basically the same stuff, but you don't see it happening.
Thanks for the pretty pictures. And I have two questions. The first one is, like, can you use any other layout algorithm? Like, for example, like, can you just like put it in Sigma? Or, and the second one is, like for the node size, like you use g.degree, right? Can you probably put in any other centrality measure too, right? If you want to calculate the node size, right?
Yes, so for the spatial layout, so here it's Force Atlas. Here you have got something which is collision repulsion, and like graphology and Sigma implemented other algorithms that you may use, but they are not implemented within ipysigma as of yet. Because in most of the social scientist community, like Force Atlas is the de facto standard, which is geared towards what we actually do. But it's doable. Yeah, sure. You could like run the layout on networkx and then like give something like node positions and give something to the layout. And you can also retrieve the layout from the widget itself. And for the second question was about the centralities and so on. So basically, the documentation is a bit is very exhaustive on the subject, but node size here is able to take a lot of different things. It can be the name of an attribute, it can be a dict mapping nodes to a value, it can be a lambda, it can be a lot of things. So if you have a way in Python to compute the centrality you want, you just give it to the widget and it will be used for you.
Yeah, I have another question. Thanks for the talk, and also the tool is really cool. Yeah, and I'm wondering on this widget, there's this visualization. Can we also show different measures, like different scores of different of the nodes in for example, the centrality measures or different properties based on so certain calculation of the network? Is it possible?
Yeah, you can basically apply any kind of computation that yields a score for nodes or edges onto the nodes and the edges. So then the choice of the actual variable that you are going to use is a choice remaining to the reader, basically. So you have to make this choice. I have some opinions about which one you should use, but the tool is completely open-ended. It's just a way for you to render an interactive graph. So you have to make a choice. Then, okay, I want to use this for the size and this for the color, and I want to tweak the color this way, but I don't make the choice for you. You are completely free.
Yeah, right. Also, thanks. And one quick question. Is it possible to also export this visualization into an HTML?
Yeah, you can embed them as HTML, and here you've got an example of that. This is basically an iframe onto an HTML, a static HTML file. And you can also export into PNG, SVG, JPEG, JSON, and so on. And you can also full screen it and print a screenshot, which also works.
Yeah. Cool. Yeah, great idea. Thanks.
I'm interested in the Sigma grid widget. Was it really difficult to have some kind of two synchronized view? Is it something that is built in sigma.js? Is it something that you had to do yourself?
It's something that I had to do myself.
And was it very difficult?
No, but I developed sigma.js, so it's a tricky question. Basically, the thing which is a nightmare is to synchronize both, and basically you have to make sure that when there is an update here, it's broadcasted to the other part, but not on yourself. That's the main issue. But the code of the TypeScript side of the ipysigma code is on GitHub, and the part which does this is actually quite straightforward.
Yeah, so if there's no other question, we can thank Guillaume for the great talk.
Thank you very much.
And the great tool.